Good afternoon. How's everybody enjoying Star Trek so far? Good? Yeah? All right. Woo! My name's Steve Jackson, and you just met me, maybe. But I'm going to ask you for a favor. So this is the first iteration of this talk. You guys are either very lucky to be on the cutting edge, or I'm sorry. And I'm looking for feedback. And you can give it to me in person, and I have a whole bag of swag if you come talk to me, or email or tweet, I don't care. But I'm looking for information about this talk. If there's anything about it that you might change, or something you definitely would not change, if you found something surprising, or if you're like, man, that 10 minutes in the middle was really boring and you should totally cut that, that's good info too. I'd love any of it. In exchange for this favor, I'm going to tell you a terrible secret about me. I come from a divided family. I am a huge Captain America fan. I have been pretty much since I was a little boy. And I've tried to instill these sort of values, but this is my son. And my wife is Team Jean Grey, if that's a thing. So this is my son. He's pretty awesome. He wore that for favorite t-shirt day. And he's 6 years old. You could probably line 30 Iron Man suits in front of him, and he'll tell you everything about each and every one of them, what the powers are, Mark 16, all this wonderful stuff. But again, I'm Steve. I work at Lean Dog just off the coast of Cleveland, just barely. And the title of this talk is, Sometimes a Locust Swarm Can Be a Good Thing, or How I Learned to Stop Worrying and Love the Swarm. So hopefully from this talk, you might get some ideas about how you start load testing. Now, I've done load testing before in my past where we either had an application with an existing use case and we knew we were going to have a big ramp up, big product announcement. We wanted to make sure we were ready for that. Or we had an actual performance problem. We need to optimize that away, so we do some load testing. But this was the first project I ever did where we had 0 users and then went to all of the users on the first day. So hopefully this will give you some ideas on where to start if you end up in the same sort of place. I'm going to talk about why we use Locust, why it ended up being a good tool for us. I'm going to talk about some of the problems that we encountered while doing our load testing and how we adjusted our architecture to fix them. Hopefully, I will make an argument for starting load testing early. And I hope this comes across as a compelling story. It was pretty dramatic to live through. Hopefully that comes through on the talk. So just to give you an idea on the timeline, what we had here was a top-level domain, .realtor, owned by a company called Second Generation. And they wanted to allow realtors to buy domains to expand their web presence. So this is a top-level domain like .com or .edu or anything else. But the use case here is that a realtor is not a leading-edge, early adopter, technical kind of person. And domain management is sort of esoteric and weird to think about. And we wanted to abstract as much of that away as possible. You don't want to deal with C names and A records and SOAs and all this good stuff that you need to do if you're setting up a domain, but probably have never thought about when you go to the websites. So we had a group of developers working on those sort of problems, and also domain registration itself is kind of a weird process. And they did that for about 7 months. And then on September 15th, myself and Eric Hankinson were brought onto the team specifically to set up the production infrastructure and do load testing. We did a soft launch on the 20th of October and our full-on general launch on the 23rd. So I'm going to talk a lot about myself during this talk, but I just want to point out that there are a lot of people involved in this. We have Charlotte, Dan, Eric, Michael, Nathan, Nick, myself, Tim, Will, and Joel were all involved in this project, especially towards the end. I want to give special shout-outs to Charlotte, who was in her 3rd week as an apprentice and jumped on Zendesk and started supporting our users. Eric, who kind of led the way on a lot of the AWS stuff initially and was my partner in crime for most of this. And then Michael Limley, who is our iteration manager on this project. And Michael went above and beyond, moving roadblocks out of the way, dealing with weird issues, jumping on grenades. I'm really, really grateful for all things that Michael did. So when we first started this, 38 days from our launch, we had this idea that we would take an iterative approach and kind of build our architecture up. Our initial architecture looks something like this. We have an elastic load balancer in front of some number of web nodes. These nodes are all Ubuntu machines running Nginx and Unicorn. We have Memcache to do session management. Postgres is our database. And then we're using simple proxy because some of our external dependencies had a whitelisted IPs, and we knew we'd keep adding web nodes and all these good things. We didn't want to exchange IP lists all the time. So on the surface, .realtor seems like a pretty simple site. You sign up. You need to be a realtor to buy a .realtor domain. I can't buy one. And then from that, you add domains to your cart and you check out. The interesting thing about this project is the sheer number of external dependencies we had at launch, and we've got more now. So you need to be a member of the National Association of Realtors or the Canadian equivalent to buy a .realtor domain. We had payment processing. We need to actually register the domain. We need to set up the DNS. We can do mail forwarding. We had a hosting option. And then, of course, we need to send emails about various things. So that's kind of a lot of things to deal with at once up front. How are we going to approach this? So we worked with our product owner to build a user funnel, an acquisition funnel of how we thought users would actually use the system. Now, this was completely made up. We had no data to work with. But based on what our guesses were, we figured of the people that entered the site, probably 75% of them would actually register for an account. Because this was not a trivial process. You had to know your realtor membership ID, for instance. And we knew that going to go look that up, we'd lose some people during that process. But presuming you registered, you would go ahead and search for a domain, see if I can get steve.realtor. Yes, I can. I want to buy it. And then some number of our customers, we figured, would want to transfer their hosting, have their domain point at hosting they had somewhere else. Like the bigger brokerages like Keller Williams and Howard Hanna will give you a website that has your properties. You might just want to point your brand new tim.realtor site to that. So working from this user funnel, we were able to identify which dependencies we really cared about. The membership, payment processing, registering, setting up DNS, and then kind of falling to the bottom was the ability to send emails and worry about mail forwarding. Now we knew from the start there was no way we were going to get all of these external partners set up to do a load test at the same time. We knew we'd want to do multiple load tests. It just wasn't going to happen. We also want to be able to test our stuff more or less independently. So we built up little fake services. I really overthought this initially. I was like, man, I don't want my stubs to be adding latency to the requests and making, don't worry about it. Like, at least in our case, these were all so simple, stupid, that they took no time, used no resources. We were returning canned data or looking at the request and then putting a response that had some of that request data in it. So we just used little simple Sinatra services for 3 of our dependencies. And then event registration doesn't use domain registration doesn't work across HTTP. It uses a custom protocol called EPP, which essentially is XML messages over TCP sockets. It's weird, but that's the standard. And we also made sure that we put these dependencies in a different region than our application was in. We didn't want to be in a situation where our application rack was right next to all our dependencies and there was no latency and no hit on our server to make these calls. So once we stubbed out all of these dependencies, we had the ability to run our application without touching any test systems or anything like that. We could just kind of go through our workflows manually. So now it's time to introduce our testing tool. I always like to give a shout out to Siege when I do performance talks. It's a brute force, crazy simple tool, but it's nice to just see, can I bring down a server with this thing? And it works well for that, but not very sophisticated. Bees with Machine Guns was our early Clubhouse leader, probably because the name is so awesome. It's really cool what it does. It will spin up an entire cloud of EC2 micros and hammer your site for you, which is neat. But it lacks some of the scripting capabilities we needed. We looked at Gatling IO very briefly and settled on Locust kind of quickly. So Locust has more or less become LeanDog's preferred load testing platform. We've used it for a number of projects now. And it has a lot of cool capabilities. This was probably my second time ever dealing with Python code. It runs on Python, so it'll run on anything that runs Python. But it's very simple. It wasn't very hard at all. So this is a Rails app, and In Rails, when you submit forms, you have to include the cross-script request forgery token in order to basically not do what we wanted to do, was impersonate someone going through these forms. So we had the ability with Locust to actually make a request and then parse out the response, use part of that to make our next request. So with that capability, we could execute end-to-end user interaction using sessions and cookies and all that awesome stuff, which was cool. And then Locust has the ability to scale horizontally. So you can run multiple slaves on a machine, and you can run multiple machines. And we did that and increase your capacity and your ability to test quite a bit. And then kind of a feature that turned out to be super useful for us, it has the ability to run different use cases based on likelihood percentages, which maps perfectly back to our user funnel where 50% of our users will buy a domain. On top of like the scripting capability, you can actually extend Locust as well. LeanDog helped teach a course at Case Western, Internet of Things type course. And the two of the undergrads there for their senior project went ahead and extended Locust to do MQTT testing. They weren't really happy with the tool that they had found before. So they could actually scale horizontally across multiple nodes and actually bring down their MQTT broker, which they couldn't do with the tool we had before. So it's pretty cool. So this is what a Locust script looks like. Each one of your locusts is just a Python class that is a kind of user or a kind of locust. In our case, we had visitors and we had registered users. And then you can weight these users. So each one of your slaves will run as many locusts as you tell it to. It'll spread them across the slaves. And then some percentage of them will be visitors, in our case 10%, and the other 90% were registered users. And when Locust runs on these slaves, each locust will run through its task and then wait a set amount of time. In our case, we used a sliding 5 to 9 second window, and then go ahead and pick up another task and run it based on the percentages that are out there. So this kind of gets you away from the sort of synchronous thing where everything happens every 5 seconds and the rest of the time it's bored. So it's more realistic this way, which is cool. For each one of your locusts, you can assign behavior classes to it, a visitor behavior. So this is our behavior for our visitor locust. And every one of our test cases is essentially just a method on that class. And the annotations you see there say, we're going to just visit the site 3% of the time. Oh, I don't know how I ended up here. I'm just going to leave. 7% of the time, we do what was called a guest search. You have the ability to go ahead and do a search without registering an account. But the other 90% of the time, our visitors would go ahead, register, and become registered users. So this is our guest search task. It's somewhat complicated. One of our business rules was that you could only buy domains that had your name in them. So I could get steveisawesome.realtor, but I could not get tim.realtor, for instance. So in order to do that, we had to essentially pop up a window and ask you for your name in order to return search results that were relevant to you. So we go to the index page, that's where the search was, pull out the cross-scripting token, shove it in the post to go ahead and say, my name is Steve Jackson, and then do a secondary post to go ahead and see if stevejackson.realtor is available. And this is what it looks like. This is pretty much all the code. Locust comes with a nice little web UI. It's pretty easy to understand. The top bar there is essentially your status. In this case, we had 2,400 users or locusts in the system running across 4 slaves, and our app was getting 88 requests per second. This was pretty early on in our testing. The big table down the left is all the endpoints that those locusts are hitting. And on the right, it's number of requests, number of failures, response times, latencies, all that good stuff. If you want to drill down into failures, you can see per endpoint what kind of failures you're getting. So in this case, I was getting a lot of gateway timeouts, the 502s. And then your Locust infrastructure needs to sit outside your application and pretend to be a user. So we set up another a cloud for that, essentially, another region. And in this case, the master node is responsible for running the web page and coordinating all the results from all the slaves. They're always publishing back how things went, and it aggregates all that data and displays it to you. So we used a 2-core machine with 8 gigs of RAM to run that process. And then our slave machines were a little bigger because the slaves are CPU bound. The number of locusts they can run, the number of slaves you can run on the machine, it's all based on how much CPU you have. So these were 8-core, 15 gig RAM machines. And in our case, at least, every instance could easily support 12 slave processes running thousands and thousands of users. But we didn't quite have that much at this point in the story. We were still in the idea of, we'll start small. Can we do 1,000 simultaneous users, go ahead and start gathering all this data, and then we'll just grow the infrastructure as we hit bottlenecks. We've got 30 some days, it'll be fine. In the meantime, while we're kind of going through this and figuring out our load scripts and our user funnels, the rest of the development team was looking at more performance-based metrics, things like adding indexes to the database, search always needs another index, loading up fake data into the database. So our load test would start from a point where we'd already sort of saturated the number of users and orders. That way we hit that, we had those hits when we did our queries. And using tools like YSlow, which will tell you, oh yeah, you need to compress this, you need to change your header this way, you need to put your CSS here, things like that. Useful tool for like optimizing a particular request and making it as performant as possible. At this point, we could do probably between 1,000 and 5,000 simultaneous users just with our infrastructure isolated. And it was time to do our first load test with an external partner. So we essentially unstubbed their request, made that real, and then went ahead and ran with the rest of our stuff still stubbed out. It went very badly. 1,000 users, 95% fail rate. So, what are we going to do? Well, we're going to make that process asynchronous so we can background it and handle errors on our side and not expose all of our users to all of the errors and queue it and slow it down and all those good things. So we moved delayed job to its own box. It would have its own processes and resources, and then our web nodes would just do their web thing. 4 weeks away, 28 days left. Around this time, we had been throwing around numbers about our user funnel. Things like, well, we expect to have 75,000 users over the first 72 hours. And if you're anything like me, my brain goes into like word problem story mode, like, oh, train leaving the station at da-da-da-da. All right, well, we got 75,000 users over 72 hours. Well, nobody's going to buy a domain at 3 a.m., so let's say 10 hours. We have multiple time zones, 10 hours a day, so 30 hours. 75,000 users over 30 hours, that's 2,000, 3,000. We probably want 5,000, 6,000, 7,000 simultaneous users to be safe. Basically, I was assuming that everyone would get in line, wait for their iPhone, and then kind of carry on. But our client had done this before. And he's like, that's not how this works. There's only one Nancy.Realtor in the world and a lot of Nancys. This is like Walmart on Black Friday. There's one big screen TV in that store and everybody wants it. And by the way, we think based on our marketing efforts that 100,000 users is probably more realistic. And immediately my brain's like, 100,000 users, and I'm at least enough of a warrior and an engineer to be like, well, we need to be able to support 200,000 users then. What are we going to do? We're going to have to turn all the knobs to 11, right? And so we started looking at our architecture, and it's like, okay, we can add more processing for background jobs. We can put in more web nodes. We can do extra caching stuff if we need. But we only have one database. And do we really want to get into sharding or distributed databases or anything like that? Well, luckily, our client with some prodding unlocked the keys and said, go get the biggest database that Amazon allows. So we got a DB-R3 8XL, 32 cores, 244 gigs of RAM, running in multiple availability zones, so you have hot swap, and then 200 gigs of disk space with provisioned IOPS, because with provisioned IOPS, the more disk space you give it, the faster it is. We're never, ever going to use 200 gigs, but that's what we did. And we still couldn't really run our load test infrastructure up to 200,000 because we just got this news. But we ran some individual stress tests and felt like, we don't know, but we feel like this will have to work. We'll make it work some way. And we had run sites in production before using Ruby and Unicorn, and we were or Rails and Unicorn, and we're pretty comfortable with that. But the way Unicorn works is that it forks a process for every single request that comes in, which is wildly inefficient. And when you start talking about 200,000 requests, that's a lot of processes. So we started looking around, seeing is there a better way to do this? And at the time, and I think it's still true, Puma was sort of the new kid and was going to be the hot Ruby web server. It's threaded and it'll work a lot better. But we started doing the research, and right there on the README, it's like, all of your gems must be thread safe. Like, what does that mean? There's no list anywhere that says these gems are thread safe, these gems are not. No, there's nothing like that. And we've been pulling in these gems for 7 months on this project. And I am a Ruby gem maintainer, and I can tell you I have never spent much time thinking about concurrency or anything like that. I built this thing to solve a problem. I'd never load tested it. I'm doing this in my free time. So we stuck with Unicorn, and we went big on those machines as well to cover our butts. 32 cores, 244 gigs of RAM. Now at this point, I've never provisioned anything this big. I've never had a machine this big, and I don't know exactly how to do it, because you start looking at the documentation, and Nginx is talking about how many worker processes you should run per core, and Unicorn's got these other recommendations, and all the Amazon documentation is talking about elastic compute units, whatever that means. So thankfully, places like EngineYard, which do provision servers all day long, have published a lot of their numbers that they use to do their provisioning. So that was very useful to give us something to crib off of and start with. So our architecture was essentially Nginx receiving the requests and reverse proxying back to Unicorn. So Nginx is handling compression and serving any static assets it can directly. Don't ask Rails for static assets, it takes forever. And everything else, we'll send it back to Unicorn. Our Nginx configuration, we set up a worker process per actual core on the machine. And then we're using a Unix socket to pass the request from Nginx to Unicorn. So I need as many sockets and file handles as I can have. 200,000 requests, give me all of them, right? 64K, sure. 64K handles and U limits, please. I don't care about keep alives at this point. I need that socket to slam shut so I can start another request. And please don't wait for something to fail, just die. We also looked a little bit at the proxy read timeouts and proxy write timeouts and the client max body size and adjusting all these parameters. I don't really have any good advice here. That's very app specific, but we did play with that some to get some better performance out of this. On the Unicorn side, we initially had 400 worker processes, kind of extrapolating from the EngineYard graph. We got that down to 100 after some tuning and testing. And then probably the important thing here is the backlog number on the socket that's open back to Nginx. We let it back up 2,000 requests before it would start tail dropping, which was good. I think the default's like 128 or 64 or something ridiculous. And then the other thing here, if you haven't used Unicorn before, Unicorn, when a request takes too long, it'll just kill it, and it won't put a stack trace in the logs or anything useful like that for you. So you need to make sure your rack timeouts happen before your Unicorn timeout so you can get information about why this request took so long. So that's what that file at the bottom is about. Need to do some ulimit tweaking here on the Ubuntu box. Again, 64K, and as many file handles as I can have. Thank you. So we've got all this infrastructure in place. Now you need to be able to actually take measurements and figure out what to do next. The load testing tools like Locust will give you information about how the user is experiencing this. What are the response times? What are the latencies? But you also need to look at your resources to figure out capacity planning. So with our EC2 nodes, we mostly looked at CPU. We really wanted to look at memory, but at the time, that wasn't an option that CloudWatch had. I think it's gotten better, like you can download Perl scripts that will report it back. But I was literally on the boxes running like top and free and wondering why my delayed job box is running out of memory and all sorts of wonderful things. Database side is much better. They've got all the metrics you could want. CPU, memory, swap, latency on your requests, how many requests do you have queued up, and then connections, which is very important. How many connections are you opening to the database? We also used Honey Badger, mostly to do error reporting, but it made some cute, pretty graphs, so I threw them in here. This is one of our load tests when we were up to 120,000 users. And we did 1.1 million orders, pretend orders, in less than 8 hours, which would have been great. If we'd done that on launch day, everyone would have gone home very happy. So to this point, what did I learn? Don't wait so long to start your load testing. We made a lot of compromises and spent a lot of money because we didn't feel like we didn't have the confidence to make big changes to our architecture. And this stuff is kind of hard to figure out under pressure. The clock's ticking. 20 days, 21 days, like not much time left. But probably most importantly, until we actually started talking about load testing, we had no idea about this requirement that 100,000 people would be there on the first day. And if I had load tested up to 5,000 or 7,000 people, on launch day I would have been sweating bullets. I would have been crying in the corner probably. So it's good to talk about this earlier. Act 3, 3 weeks from launch. So around this time, I actually went to New York to give another talk. And we had a big test coming up with one of our external partners. I was kind of nervous about it. So I worked part of the weekend, and I worked the morning of, running the test, making sure everything was stable. Everything looked good, been running for hours and hours and hours. And we're having the test right after lunch. So we're all sitting together at lunchtime, having a good time, looking at stupid YouTube videos, waiting for the thing to start. And all of a sudden, all of my tests start failing. They run consistently with no errors for 5, 6 hours at this point. And I have no idea what's going on. I stop my test, I start again, they're still failing. I restart the machines, they're still failing. This is 20 minutes before we're supposed to start our load test with this external partner. So I had to make the call. We had to cancel the load test. We had no basis from which to run and know what failures meant anything. And they had set aside time and resources to do this load test, and we're canceling 10 minutes before it's supposed to start. I felt like a huge schmuck. I imagine we looked like idiots. And it turns out we had run out of disk space on our web nodes. We knew that we didn't really care about logging to the disk because we were going to use some external service. We ended up using CloudWatch logs. So I hadn't given any thought to log rotation or anything else. It didn't matter for production. But Nginx and Rails, they still want to log all their requests somewhere. And so they filled up our little tiny SSD drives. Now we fixed this. We put some cloud init scripts in and mounted our ephemeral storage and just shoved all the logs there, and who cares? Into the ether. Don't need them anyway. But man, what a hard lesson to learn at a really bad time. The other thing we kind of noticed before the disk space thing was there are a lot of connections open to our database when things started going badly. So we introduced PG Bouncer, and PG Bouncer is really cool. What it does is it stands in front of Postgres and it keeps a constant number of connections open between it and Postgres, and then it controls all these other clients that want to get their requests in, like a bouncer, right? This thing was awesome. I went from CPU spending most of its time opening and closing connections to I don't think we ever got that thing over 6 or 7% again after that. It was bored all the time. It was great. I couldn't imagine going live without PG Bouncer at this point. So we tested again with the same partner. It's been a couple days. That test also did not go well. Not the same sort of failure rate, but we saw some weird stuff, like network layer errors, where it seemed like the client was opening up the socket and then immediately slamming it shut. And we're seeing these errors, and the third party isn't seeing anything wrong on their side. To them, it just looks like we can't drive the load. And now we start having conversations about, is someone throttling us? What's going on with the ISPs? All this back and forth and conflict. And we had just canceled the last load test, so do we even know what we're doing here? So the question came up, was Amazon actually blocking us? I mean, we're essentially running a DOS against our site. So we call up Amazon. Hey, you guys blocking us? We don't know. Really? Well, that's handled by the security group, and they work completely independently of anyone else. You'll have to ask them. Okay? And by the way, you really should have asked permission before you even started this. Oh, well, that's good to know. Can we have permission? So this took a couple days, and they eventually came back and asked for more clarifying information. And the end result was no. No, you can't do this sort of testing against your own site. We said, well, we're so far down the path now anyway, we're just going to move forward with this. So we wanted to prove to ourselves that Amazon was not the problem. Our existing site was running in Virginia, and our Locust site was running in Oregon. So in order to verify there were no issues, we started spreading out locusts and stubs all over the place. We set up in Brazil, Ireland, California, Singapore. We went to DigitalOcean and set up some stuff in Toronto. We used Linode to set up in Atlanta just to prove to ourselves that this all worked correctly. And I just want to point out how hard this would have been if not for Eric Hankinson. So if you know Eric or you meet Eric, make sure you tell him that he's a bash wizard. I was going to include a copy of the script here in the slide deck, but it's bash. It's impossible to understand. But essentially what this script would do was use our AWS credentials, look up through our account in all of our regions, find all our EC2 nodes that had the word Locust in them, filter out all of the nodes that we're not actually running right now, copy over the Locust configuration file to every one of those machines because it all has to be coordinated to work correctly, start the master process, then SSH into every single one of those boxes and start several slave processes. And then hold on to all the PIDs that made all that work. So what this experience was like for me was that I'd provision a node, and then I'd go to the master box and I'd hit start, and it would do all this work, and then I could Control-C that script and everything shut down cleanly. It was awesome. So about this time, I had this issue where I couldn't seem to get us past 120,000 or so simultaneous users. I'd keep adding nodes to the web balancer, and I might get a couple hundred more, but I really wasn't getting past this wall. At one point, I had 32 of those ginormous nodes in the load balancer, and I still wasn't getting anywhere. I'm looking at all my metrics. My database, bored. All of my web nodes, 4 or 5%, completely bored. What is going on here? Well, it turned out we need to do quite a bit of tuning to our Ubuntu instances around all of the socket parameters. Because again, these connections and sockets, they're really important. I spent probably 2 or 3 days on this. If anyone wants to tweet or ask me questions, I can point you at the sort of stuff I was reading. I think Somax con there isn't the important value. That one seemed to help the most. But we got into all this stuff. And it kind of makes sense. Linux is pretty conservative by nature. There aren't a whole lot of 32-core, 244 gig machines out there. And at least my vision of Linux initially was like this thing that you ran on your Pentium 2 from 1995 in the closet. So I could see where it might not be optimized for those kind of machines. So once we got there, we hit 150,000 users with some errors, and we kept tweaking. This is about where my web nodes ended up. We had 8 nodes in the load balancer, and they're all rocking about 80% or so, 80, 90%, which is awesome. That's right where I want them. We hit our 200,000 mark, getting almost 1,100 requests per second. The more observant of you might notice that it says 20,000 and not 200,000. One of the things we figured out was that it takes a while to actually spin up this whole cloud of users. They get distributed sort of evenly as it spins up. And when we first built the test script, we actually had a stopwatch and had someone go through the steps, and we put a sleep between each form. Well, it takes 3 minutes to fill out this form. Okay. So what we did essentially was cut all those sleeps by a tenth, and then to a tenth, and then we could run the same amount of traffic against our stubs before and after as we did. So we felt like that was a good change, and it increased our startup time by several minutes. So that was great, or decreased, I guess, would be better. I think these are the best numbers I ever got. 150,000 users, request times 1,200 per second, and then, I should have pointed on this one. So under this load, my searches are 4 seconds. Not great, but okay for a site under this kind of load. And then once this is pretty close to our final settings, if we went down to 150,000, which was closer to the target, we had rockin' half-second response times, which made me feel pretty good. So this was our final architecture, more or less. We really just introduced 2 boxes, one for delayed job. This later became rescue for a lot of reasons, but during launch it was delayed job. And then adding PG Bouncer between our web nodes and the database. So we retested with that same partner that we'd had the issues with, and it was successful. Woo! 8 days before launch. 7 days before launch, another one of our partners comes back and goes, we've analyzed the load test that you did, and we've determined that you're really being inefficient about the way you're calling our API. You're doing ABC, you really should be doing ADC. So now we're having this conversation 1 week before launch. Should we change it? What's the value? Do we have to retest everything? What's going on? This is the Friday before our launch, a few days before our soft launch. And one of our partners is like, hey, we're doing our own load testing based on what you guys did to us. And I'm like, well, what does that mean? Do I have to retest everything now? Like, I'm busy setting up production infrastructure. We're about to go live. So again, don't wait so long to start load testing. It set in chain this whole set of events that would have been much better if they'd happened sooner. But probably the primary thing I learned was that you need to be nice to people. All these external partners, you are trying to break their system. That is the point of load testing. You want to find out exactly where things break, what diminished performance looks like, figure out contingency plans, alarms, and all that good stuff for when these things happen. And if you've been running this thing in production for years and all of a sudden these schmucks are coming and telling you that it's broken, that's not a good experience. Nobody likes to hear that. I don't want you to break my toys. So you got to be nice to these people. You got to try to build up trust and relationships so you can have these conversations. All right, 3 days before launch, it's game time. So if you're using AWS, there are a few things you should probably be aware of. One is that your Elastic Load Balancer, you can put in a request to pre-warm it. The Elastic Load Balancer scales up as traffic comes in, which works great if your traffic builds, but if it's all there at once, it's not going to scale up fast enough. So you can put in a request, it takes a few days, I think, and it gets worked out. I was actually really excited about doing auto-scaling on this project, because I was like, oh, look at all this load, but it just didn't make any sense. We needed all of the nodes to be in place at first, and then maybe auto-descaling would have been useful. There are limits on the number of on-demand instances you can start in Amazon, and you need to make requests and ask nicely to get them raised. They balked when I asked for 30 of those giant nodes. Like, really? I was like, my credit's good, man. Just give me the nodes. So that took a little bit of work. And then anyone that's used Amazon before knows that if you really want an instance to start so you can do this one thing before you go home, it will, without fail, sit there on one of 2 status checks completed. And you sit there and go, I don't know, should I kill it? Should I wait? What's going on? So don't try to save money and start them up like right before because it may not work. Yeah, it's terrible. We did a soft launch. Everybody should do a soft launch. These things are great. We had probably 1,500 users. Gave us an opportunity to validate our funnel and our assumptions and make sure that users would do things. Gave us an opportunity to put in nice fixes. I never thought anyone would enter that into a fax number field. That's mind-blowing. And also it gave us an opportunity to do some straight-up hacks. Based on that small amount of load, one of the partners we didn't have an opportunity to load test with comes back and says, yeah, it looks like your requests are coming out of order to us, and we don't know how to handle that. And we're like, don't you? Okay. Well, we know how we'd fix that, but what we're going to do on our side instead is single queue all the requests to your server. We'll put it as a background task. We'll run them one at a time. It'll take as long as it takes. And we're using some software as a service components, and those have limits. Unlimited does not always mean unlimited. And it's good to find those things out so you can put messages on your thing like coming soon or all those other wonderful things that you thought would work out of the box. Then we did our product launch. So it was about 5 minutes before the launch, and we had like a window in place where we couldn't actually open for orders until a specific time. and someone's trying to get my attention, like, hey, there's 25,000 people on the site right now. And I'm like, yeah, whatever. I've been testing 200,000 all day. Like, it doesn't matter. This is actually what it was. I took a screenshot. This is the last screenshot I took, unfortunately. So you'll have to take my word on the rest of it. But that's what we had banging at the door, essentially, waiting for those doors to open at Black Friday. Really cool thing about all this load testing was it gave me an opportunity to feel what the system felt like under load. And I had all my windows open. I got my CloudWatch here, my Google Analytics here, and my Postgres queries checking on delayed job over here in this tmux window. I had all this stuff set up, and I really knew what I was going to worry about and what I should key on and what sort of errors to look at. So I felt like that was a really great thing. I felt in control of the launch, which is not a small thing. So it was really good practice. But even with all that practice, we still hit some delays. The one provider that I had worried absolutely nothing about ended up being our biggest bottleneck. Backed us up for 3 days. Assumed they would have no problems whatsoever. So that's how I spent my next 3 days, was trying to push all these orders through. But all in all, it was a big success. We did not have 100,000 users at the front gate. We had somewhere between 10 and 20 immediately, and then we had a steady 10,000 for the first hour. And we ended up doing 75,000 orders over the first 48 hours. So it was successful from a business standpoint, and everyone was pretty happy. So the aftermath. Asynchronous tasks are a good way to solve a lot of performance problems, but there are some trade-offs here. First off, you have to think about how the user has just been cut out of the loop. So if they make errors, how are you going to tell them about them? What are you going to do about it? And then I was very much a proponent of making as much asynchronous as possible because I watched the dumpster fire. And I was a little hasty, I think, in some ways. We had one particular synchronous check that we were doing, and I made the argument that, well, we're the only ones using this API in this way, so we know what's going on, and it's okay if we don't make that check, and we'll just catch it on the back end. And I don't know if it would have helped, but it certainly caused problems that we did not do that check when we could have. So I think part of the problem here is that didn't spend a lot of time thinking about some of the failure cases, of which that was one. The other is when you start doing like background tasks, you have this need and desire to retry things when they fail. I could probably do an entire talk on background tasks, but one of the problems that we had was you'd be going through a flow and it would fail in the middle. And then at that point, can I rerun the whole thing? What will that do? Was the first part destructive? Like there's this, you have to kind of make your task item potent, and it's not something that you necessarily think about when you're writing the code. You're like, oh good, I got this first request at this REST API, and I did the second request at the REST API, and I'm going to push these together and then push something out on the third post of the REST API. But when a system's under load, that second request in the middle might fail, even though the first one worked fine. And it's kind of a weird thing to think about, but that's sort of what you end up with. And then again, you can't feed these messages back to the user. And I gained a lot of empathy for my users during this. I felt really bad about all those orders getting backed up. In the domain business, it's sort of understood. It's going to take time. The number we throw around is 24 to 48 hours. And DNS propagation does take a while. But it's got to be a bad experience for someone who doesn't understand the web and has no idea what's going on. I expected to have this cool new website that I could show people, and I don't know what's going on. And it'll be 2 or 3 days till I actually get it. So, kind of sucks. I spent a lot of time with this load script. I spent a lot of time trying to optimize it and make it as good as possible, and it wasn't reality, right? Users do weird stuff. So there's a disconnect there that you kind of have to be aware of and be careful of. And this stuff is expensive. Like, we had stood up an entirely different environment to do load testing. I couldn't imagine doing it any other way. And each one of those tests takes time and resources to run. And you get back all this data, but it's sort of weird what it means. And you're like, well, maybe I'll try this, or I'll try this, or I'll try this. And a lot of times you end up, well, I'll just try all three of them. And I'm probably not going to retest because I don't have time. I got something else I need to do. So it's hard to be like methodical about this, I guess, and not spend a ton of money or know exactly what you're doing. But in the end, I'd say it was worth it. Definitely uncovered a lot of problems we would have had otherwise, which was good. Definitely do it again. These are the questions that come in my mind when I start thinking about this stuff, sort of the natural questions, and I don't have the answers to these. So if you do, come talk to me. But I feel like part of the problem here is that it's testing, and all testing has a tendency to get pushed to the back of any process. And it doesn't make sense to start load testing the first day, but there probably is a point somewhere along the line where it does make sense. And could you do this incrementally? Like I feel like it's almost like integration testing. We've learned through continuous integration, things like that. You want to do that stuff every day, immediately, all the time. Is that a way to make this cheaper and easier? I don't know. But if you have opinions on that and want to come chat with me, that would be awesome. That's all I have. I'm Steve. Come talk to me. I have swag. And thanks so much for your time and attention. I really appreciate it. Are there any questions? Yeah?
You know, Locust, you mentioned about it being compatible on Rails. Is it compatible like with Java or .NET, you know?
Yeah, so we used it to test a Rails app, but it's just Python code. It can run anywhere with Python, and it ran on its own machine even. So you could, if it has web endpoints, you can test it easily, and even if it doesn't, you can extend it to test. So it's pretty much a standalone tool. The actual programming language doesn't matter. Anything else? Great. Well, thank you so much.